Hey everyone, welcome to the 7th episode in the PongGDX tutorial series. In this video, we're going to do a little bit of code refactoring, along with setting up our first paddle. Now, to accomplish this, how I've approached it is I will be setting up a sensor box body on the left and right hand side, and I will also have two other box bodies, and they will both be connected to the respective sensor box bodies on the left and right via a prismatic joint. Now, if you haven't dealt with joints before in Box2D, I definitely recommend checking out some of my other joint Box2D tutorial videos. I know they have a lot of helpful information in them, and they'll definitely give you a little bit of a jump start on how to approach a lot of problems like this with using joints in a game mechanic way. So yeah, it'll give you that leg up. Otherwise, I will definitely still be talking about the code as I go through it. So anyway, let's jump right in. So if you remember last time, we had our chain shape set up, and we also had a ball that will represent our Pong ball. So let's get out of here. One of the first things that I want to bring forward is a little bit of a code revision. This was mentioned by Terry Rao, and apologize if I pronounce that wrong. He had asked me, why did I put the create walls method and with all this Box2D creation stuff in the game screen? Now, that actually made me think a bit. That's a good thing to think about, is where you're placing things with respect to what class you're working in. We're doing a lot of Box2D work in here as far as creating a body, and that's a good thing to note. And there's a better way to do this without making it, or with actually making it more flexible for us in the future. So if we ever did need to make a chain shape, then we just have this utility class that's already built up for us, and then we can actually use that utility class in other projects. So it's almost like our own little defined utility library for us. So we're going to abstract this a little bit more and move a lot of this code out and into the Box2D body builder. And how I'm going to approach that is I'm going to keep this vector2 of vertexes, because that's still relative code to what we're looking for as far as creating our walls. However, I'm going to move a lot of the Box2D body, the body def, and the body creating fixture and whatnot. I'm going to move that out and into the Box2D bodybuilder class. So I figured it might even be a good exercise for you guys to see that design decision being made and understanding why that is a reasonable decision to make. Originally, I had just seen that this code could be in here because that's all it's doing, is creating walls specific to the context of the screen it's working in. So it's fair to say that this is still okay to have in here. Design-wise. However, it's even better to have a method that just creates it for us, that we can ask for it instead, because this class seems to be doing a lot of Box2D body creation stuff, and we might as well let it handle all of that stuff in general. So we're going to be creating a public static body. We will want body because that'll return the chain shape for us in case we ever want to modify it. Although I don't think we'll be keeping reference to the wall because that's unnecessary. It's just a line, and we don't really plan on moving it or anything. And so that's going to be create chain shape. Okay, and this is going to take a world, and I believe it just takes a vertex 2 array, and so that's going to be verts. Oh, is that vertex? Or I'm sorry, vector. I'm thinking of GLSL shaders. Vector 2, and then import that. Okay, and so we can go back into our game screen, take all this top code out, and you'll notice I'm leaving the verts all alone. You can come back in here, paste it. Okay, it's going to be static. You know what? I'm actually also going to add a boolean in here, and that's going to say whether it's is static. There we go. Yeah, so that'll allow us to have a little flexibility on the body type. Although I guess that's not really necessary. You know what? I'm not actually going to do that. It's a little overhead. So, yep. So we'll keep that, and then we'll have a shape dot create chain, and that's going to take in the vector 2 of verts. And then what else did we have? So we had create chain, and then we had body dot create fixture. So we're going to take all that bottom stuff out, delete that last part, and bring all that over. And then we're going to want to return the body that we created. So just to break this up a little bit so it's more readable. Okay, so yeah, that all looks good. And we can come back to our game screen. And so create walls is now going to make a call to b2d bodybuilder dot create chain shape. That's going to pass it the world, and it's going to pass it the vertexes, and that's all we have to do. And so because we got all that set up, and we just can run our game, just make sure that's all working right. And that should allow us to have a little bit more flexibility as far as where our Box2D body creation code is going. And yep, so we get the same output. So that's exactly what we're looking for. So now that we've done that, we can move into creating our Box2D joints and our Box2D sensor and the paddle box bodies that we'll be working with. So the first thing we'll want to do is figure out how we want to create these sensors. And I think the best way to do that would be to come to our Box2D bodybuilder. And if you remember, we have this create box method up here. And so we can reuse that. And we just have to make one small change. We need to say whether or not it's static or if it's a sensor also. So that's going to be 2 booleans, and that's is static, and then boolean is sensor. Okay, and so then we can have in here is static body, or body def dot body type dot dynamic body. Okay, and if you've never seen a ternary operator in any kind of language that you've been faced with, it's pretty much like you can do a statement check here, and you put a question mark, and so you're putting that statement in question, and if this is true, it uses the first statement, the first part of what's in the ternary operator, and if it's false, it uses the second part of the ternary operator, and that is delimited by a colon in the center. So like, if it's true, do this. If it's false, do that one. So just for those who haven't seen that syntax before, that's just some shorthand that I'm going to be using. So now that we have that, we also want to come down to our fixture, and it has that is sensor boolean that I talked about in previous videos. We're just going to come in here and then have is sensor. So that's simple enough. We just have to take that variable. If it's true, it'll set it to true. If it's false, it'll set it to false. So now we have a little bit of a more flexible create box method that we'll be able to use to create both our paddle and our sensor box that we're looking for. So now let's go back into our game screen, and we will want to make references to these sensors and the paddles. So first, let's just start with the left sensor and the left paddle. And so that's going to be, how should we name these? So we could say left paddle, but I think I'm going to say paddle left and goal left. I might actually separate those out just to have them a little bit more readable because they're relative to each other. And we might as well have body dot paddle right, goal right, just because we will be making those later. And these will be game objects, or rather game bodies. And so now that we have those, we can kind of, you know what, we should actually do some revisions in the show method now that we're going to be doing a lot more setting up as far as the game objects that we're going to be working with, because now we have our walls, we have the ball, we have the goals, and then we'll also have the paddles. So let's do Init Arena, how about? And then we can come down here and have our Init Arena be above all the init methods, such as like the create wall, set up the ball, set up the paddles. And so that's going to be private void Init Arena. And then we can do this code right here. Just take that out and bring it down into our Init Arena. And so this is going to set up our Pong ball, our Pong walls, and everything else. And so we have our paddle left is going to be equal to b2d bodybuilder.create box world. And I believe, you know, it really won't matter right now what the XY is, but we should probably check what the width is. I'm going to do camera. So the left one will be, I'd say it'll be about 20 pixels out. So maybe like the X will be 20. The Y will be camera.viewport.height divided by 2. The width should be, I'd say about 8 by 16 maybe. And then it's not going to be static, and it will not be a sensor, so that will also be false. So let's just check what we get with that real quick. Okay, so yeah, that is a lot smaller than I thought it would be. Let's try something a little bit bigger. Let's try about 10 and 40. So I believe that's what I tested with roughly. So that should give us a little bit bigger of a number. Oh yeah, that looks way better. So in comparison to the ball, maybe the ball will be bigger, or maybe the paddles will be bigger. Those are things that we can change later. But for now, let's get the actual mechanic in first. So I'm gonna move it out to about 40 out. And then we can also do, you know what, might as well get the paddle right in there also, because that's a simple copy paste. All right, this is going to be camera.viewport.width minus, I believe, so that'd be the width minus, oh, that'd be 45, and then, yep, that should be where we want it. So let's check that real quick too. Okay, I think that's about right. Maybe it should just be 40. But anyway, so yeah, we'll just change it to 40. So now that we have the paddle set up, let's get the goal sensor set up. So that's going to be goal left equals b2d. You know what? We could actually be irresponsible and just copy and paste that because I'm going to be lazy here. So goal.left or goal left is going to have a X of, I'd say, I think 5, and then the width will still be 10, and the height will be camera.viewport.height, and so it'll be as high as, as high as the screen, and that'll be divided by 2, or I think, yeah, no, I divide by 2 in the method for the height and width, I believe. So let me check that. Yep, okay. So I do that with respect to how yep, okay. So now we have a sensor, and you'll see that we should actually make that static. I mean, I guess we don't have to, but we don't want any chance of it moving. So we'll make that static, but you can see this pink line here now. That is actually our box that we made. And because we set the sensor, which is still false actually, that should be set to true. Now it is a sensor body. And actually, I'm pretty sure sensors should just be green by default. Otherwise, yeah, okay, so we do just have to make it static. So we'll set both of those flags to true. And then, you know what, like I said, might as well just copy and paste because it's as simple as that. goal left and goal right. And the X will be camera.viewport.width. And that's going to be minus, should be minus the, I believe, 10. Let me see. So it's 10. I should put it in the right spot. Hopefully. Okay, put it a little bit too far out. Maybe it's only supposed to be 5. But anyway, so now you can see how we're going to be setting this up. It's going to have these 2 sensors and these 2 paddles. These 2 paddles are going to be connected to these sensors in a way that, if you're unfamiliar, like I said, with Box2D joints, it will allow us to have this paddle slide along a vertical axis, and that way it won't have any like X and Y influence or X influence that we have to care about when the ball gets hit by, or when the paddle gets hit by the ball. So when the ball comes in and hits this box body, it won't move it to the left or like move it back. That way we don't have to care about that. We can just keep our paddle on this or single X point in our world. And that'll make things, as far as like figuring out how to get our ball moving around, a lot easier in the long run. So with that, let's get into setting up our prismatic joint. So this might be something that we could put another class for this. Let me think about this real quick. I actually didn't think about this ahead of time. So we could have this in another class where it's a B2D joint builder. You know, I think I am going to do that because there are a lot of different kinds of joints. Granted, we won't be creating probably any other kind of joints down the road, but who knows? Maybe we'll have like special properties that you could pick up with your Pong paddle that'll join the paddle to the ball in a weird way or something. So yeah, we'll just do the Box2D joint builder utility class. And so this is going to be another static class. So of course we'll want a private B2D joint builder constructor. And then we're going to have a public static. This will return a joint, which is a Box2D joint. We're just going to return a generic joint, not a prismatic joint, for implementation or design reasons. And then that's going to be called, let's see, we should call this create prismatic joint. So with joints, they require 3 things, go figure, as most other things in Box2D require you to set up. How we have our body. You have a body definition, you create a shape, and then you create a fixture definition, and then you have your body. So joints are kind of along the same lines, where you have a body A and a body B, and then you also have like the joint description, and then you just create the joint, and it will resolve itself as it should. There's also like, you can set limits to how the joint works, which is also an important thing that we're going to be setting up today as well. So for create prismatic joint, like I mentioned, we're going to need 2 bodies. So we have body A, import body, and we're going to have body B, and then we'll figure out the rest of the method signature once we start getting into creating the joint. So we're going to have prismatic joint def, and that's going to be, we're just going to call that pdef for short. Import prismatic joint definition, and then that equals new prismatic joint def. We're also going to have, actually above that, let's have our joint, and that's going to be the joint, just like we see when we create bodies. And then we'll also need to pass in our world. That's right. So world import the world class, and we'll have to return world.createJoint with that pdef. So actually, you know what? Yeah, we don't need that, because we'll just be returning whatever that returns. So now that we have our joint definition and the world to work with, we can say pdef.bodyA equals body A, pdef.bodyB equals body B, and then this is where things get a little interesting. So now we have a few other things, a few other public variables that you can see in this list that are available for joints. And I'll kind of run through them real quick. Local anchor A is kind of where the body A is positioned with respect to the center of the joint. So that's kind of like a vector position outward away from like body B. And then you have the local anchor B, which is vice versa of that. So like you are setting the body B position of the joint to be extended by a vector with respect to the center of the joint in comparison to like where body A is. And then you have the upper translation. This is kind of like your upper limit for the prismatic joint. Prismatic joints work like sliding hydraulic joints, so you can think of that as like a sliding door almost. And we're going to be using that, as I said, like to slide the box up and down, and it'll be along that y-axis. So our upper translation will be however high we can put our paddle in the game screen, so like the top of the window. And then our lower translation is going to be to the bottom of the window. I don't think I'm going to get into the motor force stuff, because that's more for motorized joints. Those are like active joints. If you want to see that stuff, definitely check out my tutorial videos. Like I said, I have a lot of pretty good material on Box3D joints. So otherwise, there's also the, where is it? Reference angle. This is I forget what that's for. I think that's the reference angle that the angle or the joint is oriented. And then you can also set the local axis of A, which for a prismatic joint, we're actually going to be using this. So I'll actually show you this, guys, show you this in practice of what this one does. So we're going to need to set the collide connected Boolean to false. We don't necessarily need to set this to false, but just for the sake of working with what we have, collide connected means the two bodies that you're joining will not collide when they're joined by this joint. It's kind of a nice property to have, especially if you're making larger bodies with a lot of fixtures. So a more physical, real body, if it has like arms or something, and you say collide connected true, then the arms would collide with the body of, the body of the Box3D body and all the other fixtures that are tied to that body with the joints, or rather just the body A and body B that you're joining. And so we're just going to set it to false for the sake of not having anything messy happen. And then we're going to have pdef.enableLimit, and that's going to be set to true. And that's because we want the upper and lower translation limits to be in effect. And then we're going to set the pdef.localAnchorA.set. We'll need something special for this, because we need this to work for both the left and right hand side, because it's going to be mirrored depending on what side we're creating this joint, and we'll see that in a second also. For now, I'm just going to set it to 16 divided by ppm, which we also need to do a static import on. Almost forgot about that. Static com.Connor Anderson pong utils b2d constants ppm, and then 0 for the other part of that. And I'll tell you guys what this looks like once we build it up. how that influences what we've made. And then I'm also going to set the upper translation, so pdef.upper translation equals, this is where we need some more variables in our method signature, I believe. So we should have a float, upper limit, and then float, lower limit, if there is one available. And so that's just going to be upper limit divided by ppm, and then pdef lower translation equals lower limit divided by ppm. So easy as that. And now that we have those things set up, we actually should be good to be creating our first joint. And yeah, let's go over to our game screen now. So we're going to want to come into our Init Arena, and because we have these 4 bodies here, we're going to be wanting to create 2 prismatic joints between the 2 sets. So we'll have b2d joint builder dot create prismatic joint, pass it the world, and body A, I believe, should be goal left, and body B should be paddle left. And then we're also going to want to include the upper translation limit and the lower translation limit. Now, the upper translation limit is just going to be the camera dot viewport height, and we're going to divide that by 2, and we'll see what we get there. Oh, and we need a lower translation limit. This is just going to be negative camera dot viewport height divided by 2. So it's pretty much just the opposite, because it's the same height up and the same height down, because we're just starting from the center. So let's just see what this first prismatic joint gets us. Okay, yeah, so now we're seeing a different color in our Box2D debug render. That's that blue line, and that is how Box2D renders joints. So the only problem is we don't really have a way to test if this joint works the way we want it to. So we're going to have to implement some loose input code. This, of course, is going to be refactored once we get farther along in our project. But in order to test the joints, we need some way to interact with our game world. But for the time being, we can clearly see that the joint is connected to the center of this sensor and the center of this paddle. So we're very close. We can definitely see that things are coming along the way we want them to. But let's come into our update method and come down here. And also, I realize that because the application.appfps is an int, I know this is kind of sidetracking a little bit, but that's because that's an int. This is actually a integer rounding. This is erroneous by doing integer division, and so we need to just change that to a float, so it'll do float math and give us the right world.step. So that was one thing that I actually should point out, and I'll put that in the description, of course, for those who are kind of skipping through my videos, so you can make sure to catch that. I noticed that the other day. But anyway, so back into our update method, we're just going to have something that will allow us to follow our mouse. So the mouse is kind of the easiest input to control, and or rather observe, because we can just get the mouse coordinates and then tell the Box2D body to move with respect to where the mouse is. So let's see. So we have our float mouse position to world. Bear with me for a second. I'm just going to type this out. gdx.input.getY, import gdx minus camera.viewport height divided by ppm. Okay, so what I'm doing here is I'm going to be turning this into world coordinates, because anytime we get the Y position of our mouse on our game screen, that's going to be with respect to our screen, not our world. So it won't be in the same units that our world is working in. And that again is why we divide numbers into our world and multiply them out of the world. So that's just one of those observations that you need to take into account when you're working with input from the player. And because I want to kind of have a smooth position, I'll get to that in just a second, but you'll see an interpolation step that I'm going to be introducing later. But for now, we're just going to get the player dot, or I'm sorry, that should be paddle left dot set transform paddle left get position dot x, and I believe this should be mouse position dot world, or to world, and then this is also going to have player, or I'm sorry, paddle left get angle. So that's just part of the parameters that set transforms takes. It needs the X and Y and then the angle of the body. Of course, our body doesn't rotate, but that doesn't matter. Set transform requires you to have that get angle as a parameter. So let's see if this is doing the right thing real quick. I'm going to comment on this. Get mouse position move paddle. We're going to put a to do here, revise. Okay, and okay, well, this is close. I'd say close. However, you're going to notice that the upper and lower translation is obviously not working right. So that'll take a little bit of tweaking, but we can see that our paddle is moving how we want it to. At the least, it's moving on a Y. It's only changing on the Y axis, which is good. It's not moving on the X, unless we're just not observing that is. However, this is exactly what a prismatic joint should be doing, just keeping a body along a single hydraulic axis. So I'd say we could be done here for this video, and then could go into refactoring in the next one, as this one's getting a little bit long. So I think I'm going to cut it short here, but let's do some review. You'll see that what we have is it's pretty okay. It's a paddle that moves. Of course, there's no upper and lower limit translations for some reason, so we'll have to look into that. It might be a few numbers are off, and that might just be why we're getting that weird outcome. But we have our Init Arena. Let's make some comments in here. So set up paddles, set up goal sensors, create goal to paddle joints. Okay. And then create walls just does exactly what it says. And let's see, what else might be good to comment on? So we made a note to revise this. It's always good in Java, especially. Anytime you need to make a note, you can always just type this to do with a colon in all caps. And I know in IntelliJ, it'll automatically like highlight it yellow for you. And they're also really easy to find because they make these blue stubs on the right. I'm not sure if you guys can really see that. Might be a little too high resolution and not easily visible on YouTube, but there's these little blue tagged marks on the right on the scroll bar, and you can actually click those and it'll take you to them in the code. So if your code base starts getting really big, then you can easily just come back to it. And they also give you like code previews so you can kind of see what's going on in there, which is actually pretty cool. It's kind of like a little microscope into what's going on in your code. So with that, I think we made enough good revisions, and we also added a lot of code, and a lot of things got done today. So I think I feel pretty good, and we'll hold off to making corrections in the next video. Sorry to leave you guys hanging, of course, but Don't want this to get too long. So with that, hope you enjoyed what we've done so far, and I'll see you next time.